Hello, this is my Physics 2212 Lab 3 by me. Um, this lab, the purpose was to measure the magnetic field of a bar magnet using experimental methods and to also create a model to compute the magnetic field of the bar magnet. And then we'll also compare the results of of the magnetic field from the model and the experiments. Well, you can see the results here. The magnetic dipole moment we worked out to be 1.824. In the experimental 45-degree field, we got 7.82 times 10 to the minus 5. But in the simulated 45-degree field, we got 3.55 times 10 to the power of 5. And then we concluded that as the magnetometer moves closer to the magnet, the measured X component of the magnetic field increases. And when the magnetometer is very far away from the magnet, the measured X component of the magnetic field is near zero. Okay. So the physics principles that we'll be using in this lab will be the Biot-Savart law, and then we will be using the electric dipole kind of formula, and also we'll be using the magnetic field formulas too, and the magnetic field at a distance r. So the initial conditions, we took the magnetic field of the Earth to be 5 times 10 to the minus 5. So the system was the observation point, which was basically just the phone magnetometer at the surroundings was the bar magnet and the assumptions is that the bar magnet is treated as a perfect magnetic dipole. So these are the procedures. We set the experiment by placing a bar magnet close to your phone, and then use the phone to measure the magnetic field. Then you would orient the phone so that the X component of the magnetic field is 0. And then we would measure the distance on axis at which the magnetic field is 20, 70, 120, so on. And then we would measure the magnetic field at a 45-degree angle from the magnet such that the X and Y distance are equal to the X distance from where the magnet from the magnet where the magnetic field is 100. And then repeat the procedures many different times just for accuracy. So these were the observations and results from the spreadsheet. Yeah. And then here's some of the snippets from my coding. And, yeah, and then more snippets from the coding to the 45-degree one. And then these are the results of the code. So basically just going back over what it said. So the net B field on the axis at 0.146 meters is that. And this is greater than the B field calculated in the experiment, which was 70. So, and then the net B field at 45 degrees was also less than the net B field calculated in the experiment. So the possible sources of error, there are probably other magnetic fields from the electronics interfering with the results. Could that be phones, tablets, computers, tie things around? Yeah, it could be a lot of things. Movements of phone or magnet during the during measurements, and also inaccurate measurements. It is just a phone app, so it's probably quite inaccurate around measurement errors with the magnetometer. So what if we hadn't oriented our experiment to compensate for magnetic north and had instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So if the magnet were at an in the intermediate angle, the X and Y components of the magnetic field would be affected by the Earth's magnetic field. The Z component would still remain unaffected because we measured it from a flat surface. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect the measurements to differ? So, the observed magnetic fields would increase as the magnets would both produce magnetic fields and have a total magnetic field about twice that observed. And also the distances for each magnetic field would increase due to the stronger field. So that's the end of my lab. Thank you for listening. Thanks.